So we have to now check out that if we have two convergent sequences, but uniformly convergent sequences, whether their sum and product is also uniformly convergent or not. But before that, let me tell what happens in case of pointwise convergence. Suppose you have two sequences, Fn and Gn, and suppose Fn converges pointwise to another function. Pointwise converges means at each point, this sequence of numbers will converge to this number f of x for each x. This is the pointwise convergence. And another sequence Gn also converges to the function g pointwise, and hence it converts each point, it converges to g of x. So let us fix x be fixed. Then from sequences, we know that sum of convergent sequences is convergent. Hence, this sum fnx plus gnx, its limit is going to be the sum of the limits, and the sum is f of x plus g of x, and this holds for every x wheresoever this pointwise convergence happens. And what it says that at each point this sequence fn plus gn is a convergent sequence, and hence it implies that this fn plus gn is pointwise convergent. So in case of pointwise convergence, we do not read any separate theorem or something to establish that the sum of pointwise convergent sequences is again a pointwise convergent sequence. Likewise, in case of product also, if you have these two sequences fn and gn, and if they are pointwise convergent, then for each x, you see that this sequence fnx dot gnx, this is a sequence of numbers, and it is a product of sequence of numbers, and of course it has to converge to the limit of the individual sequence fx dot g of x, and this way, hence it follows that this product of sequence of functions is pointwise convergent. And likewise for difference of two sequences which are pointwise convergent, and the quotient of sequences wheresoever it is defined is pointwise convergent. So it's the pointwise convergence is a kind of it has much similarities with the convergence of numbers, but whereas the uniform convergence is concerned, we have some changes in certain operations. For in some we will not have any change, but in case of product of uniformly convergent sequences, we will have extra conditions. So let's first prove that when two sequences of functions are uniformly convergent, then the sum, which is again a sequence of functions, is also uniformly convergent. So the theorem is let fn and gn be converging uniformly on some set A to f and g respectively, then their sum, sequence of sum, converges to f plus g uniformly on A. What is given to us, we have two uniformly convergent sequences. We have to show that fn plus gn is uniformly convergent, and to show that uniformly convergent, we will use only the definition, and for definition, let's begin with epsilon greater than 0. Then apply the definition to fn first, and then definition of uniform convergence to gn. Then according to the definition of uniform convergence for fn, we will be able to choose a natural number, which first I have denoted case of f epsilon. It depends upon epsilon. I have given this notation f just to mean that this will be used for the sequence Fn, and another natural number kg sub epsilon, such that this distance of Fn x minus fx is less than epsilon by 2 for all and greater than or equal to kf, and it will also hold for every x in A since the convergence is uniform. And similarly, since the sequence of Gn is also uniformly, so the Gnx minus Gx will be less than epsilon by 2 for all n greater than or equal to the and another number which is Kg, and this will also hold for every x in A as the convergence is uniform. This is given. Now what we have to show, our aim is to show that this sequence Fn plus Gn is uniformly convergent. For that, I need to show the existence of some natural number k, which only depends upon epsilon, so that for any n larger than that k, this fn plus gn plus at x of f plus g at x, this distance, I have to show that this distance is less than epsilon for all n greater than or equal to k epsilon. But we have to first establish this number k epsilon, which depends upon only epsilon. So what this k is going to be, let's first get, we're going to get it from this kf and kg. How we are going to get this? We are going to take this k to be maximum of these two numbers which we have obtained for regarding the convergence of fn and gn. And now see, kf and kg only depend on epsilon, and hence k will also depend only on epsilon. Now let us choose a number which is greater than or equal to k. Then obviously when n is greater than or equal to k, k being a maximum of kf and kg, so n is going to be greater than or equal to kf as well as from kg, and so we may apply these two equations will hold for this n also, because these equation 0.1 holds for n bigger than or equal to kf and k, and hence it will hold for, we are choosing n to be greater than or equal to k, so n is always greater than or equal to kf, and similarly for equation 0.2 as well. So now we have to show this number to be less than epsilon, but let us readjust it. I can write this fn plus gnx as fnx minus f of x plus gnx minus g of x. Then what I have to do, I have to apply the triangle inequality, and I will club this number and this number. Then by triangle inequality, I have this number to be less than or equal to fn x minus f of x plus gnx minus g of x. And note that we have chosen n to be greater than or equal to k, and this will imply that n is greater than or equal to kf. And whenever n is greater than or equal to kf, you will have this fn x minus fx less than epsilon by 2. And n greater than or equal to k will also imply that n is greater than or equal to kg. And whenever n is greater than or equal to kg, then this distance gnx minus gx is less than epsilon by 2, and hence this epsilon plus epsilon by 2 plus epsilon by 2 is equal to epsilon. And what we got now, finally, if you combine everything and see what happens, you begin with some epsilon greater than 0. You begin with some epsilon greater than 0. Then you found a number, natural number k, which depends only on epsilon, such that whenever n is greater than or equal to k, then this distance fn plus g minus f plus g is less than epsilon for every x in A. And this is exactly the definition of the uniform convergence of this sequence fn plus g, and hence this shows that this sequence fn plus gn converges uniformly to this function f plus g. Is it okay?
Yes, sir.
So this was the for this sum. For sum, we do not have any trouble. इन केस ऑफ सम हमारे पास कोई दिक्कत नहीं है, सिंपली कोई भी सीक्वेंस है जो यूनिफॉर्मली कन्वर्जेंट है तो उनका सम भी यूनिफॉर्मली कन्वर्जेंट होगा। तो सिमिलरली आप डिफरेंस के लिए भी आप इसको शो कर सकते हैं जी, एग्जैक्टली सेम प्रूफ होगा कि अगर एफ एन कन्वर्ज करती है ये जी एफ को यूनिफॉर्मली, जी एन जी को यूनिफॉर्मली कन्वर्ज करती है, तो यू मे शो दैट एफ एन माइनस जी जो होगा, जी एन जो है, इट कन्वर्जेस uniformly to f minus g. And not only this, you can simply show on the same line that if c is constant, c is constant, then and fn is a uniformly convergent sequence, then c dot fn, you may see that it converges uniformly. I'm going to write it uniformly to c dot f, okay, where c needs to be a constant, then it converges uniformly. So this is a scalar multiplication. That means if you multiply by scalar, in scalar multiplication, this uniform convergence is preserved. It doesn't change. Okay. And under addition and under this difference also, this uniform convergence is preserved irrespective without putting any conditions on the sequence fn. And you have to try these two exercises. You have to try these two exercises. Okay. So now we have another result. We have this result for the case of uh, product of the uniform convergent sequences. Let's read the hypothesis. It says that whenever we have two sequences, let fn and fn, gn be sequences of bounded functions. So we are having here a function, but we have some condition. That function needs to be bounded. What is a bounded function will be told, such that these converge uniformly on a to the function f and g, then their product is also uniformly convergent to fg. So we are not taking arbitrary sequence of functions which converge uniformly to f. We are taking bounded sequences. Be careful. We are taking a sequence in which each function is bounded function. So here it is conditional. You can say that you have extra condition, and we will give also an example where the product of uniformly convergent sequence may not be uniformly convergent sequence. That means, and hence that's why we have used, we require this sequence in each function in the sequence to be of certain kind, and that kind is bounded function. Let me see first what is a bounded function. Here is in definition 2 the definition of a bounded function. Suppose you have a function phi defined on a set A, it is real valued, and then we want to know what function has to be a bounded function, and then we say that phi is a bounded function if and only if its range phi of a is a bounded subset of R. You know that phi of a is the range of this function phi, and it is a subset of R. And if this subset is a bounded set, and you know what is a bounded set, if this set is a bounded set, then we will say that the function is bounded. That means function bounded होगा अगर उसका range bounded होगा, ठीक है? तो इसका मतलब है रेंज बाउंडेड होने का मतलब है आप बाउंड रेंज में कैसे एलिमेंट है, फी ऑफ ए में इस तरह के एलिमेंट होते हैं, फी ऑफ एक्स इमेजेस होती हैं सारे एक एलिमेंट्स की। तो अब ये बाउंडेड है तो यू विल हैव सम बाउंड फॉर इट ना, तो this means that there is some minus m and m such that minus m less than or equal to phi of x is less than or equal to m for all x. बाउंडेड की यही डेफिनेशन इन्फीमम और सुप्रीमम भी होता है, बट आप माइनस एम और एम भी लिख सकते हैं, ये हमने रिजल्ट किया। या इसी चीज को आप ऐसे भी लिख सकते हैं, माइनस एम की जगह यू कैन राइट मॉड ऑफ फी ऑफ एक्स इज लेस देन इक्वल टू एम, ठीक है? तो दैट मीन्स बाउंडेड फंक्शन का रेंज बाउंडेड होना मतलब इमेज हर एक पॉइंट की इमेज का मॉडुलस जो होगा that has to be less than or equal to some m. So we have to see, and to prove the theorem, we required another result which I have named to be lemma, and lemma is something which is required to prove the theorem, and this lemma states that uniform limit of a sequence of bounded functions is a bounded function. The first thing we have to show that if we have a sequence of functions and suppose that this sequence of function converges to function f uniformly, and each fn is a bounded function, then the limit function is also a bounded function. So this is a property, boundedness is a property of a function. Maybe every function doesn't have this property, and uniform convergence is a phenomena, what we say, and this property being bounded is preserved under uniform convergence. This is one of the characteristic property of what we may say of uniform convergence. So in proof, let us take a sequence of bounded functions, and I have taken the sequence of bounded function to be fn on some set A, such that this sequence converges uniformly to some function f on A. So now, by definition of uniform convergence, if you take any epsilon greater than 0, or let us say I have taken here epsilon equal to 1, it needs to be only positive numbers. I have taken a particular choice of epsilon. So by definition, for epsilon equals to 1, there will exist some natural number, let that natural number be k. Obviously, it will depend upon epsilon, such that the distance fnx minus fx has to be less than epsilon, and here the epsilon is 1. So this distance fnx minus f of x will be less than 1, and it will hold for every n bigger than or equal to k and x in A. Okay. So let us take m prime be a positive number such that since each, according to hypothesis, it is given to us that each function in this sequence is a bounded function. So in particular, fk is also a bounded function. So there will be a number such that fkx is less than or equal to m. It has to be m prime because मैं m prime ले रहा हूँ. fk of x is less than or equal to m prime. ठीक है, ये बाउंडेड फंक्शन है तो आपके पास यू विल हैव दिस सिचुएशन. ठीक है, दिस इज बाउंडेड. नाउ इस इनइक्वालिटी 0.3 में जो आपके पास इनइक्वालिटी, इस इनइक्वालिटी को फिर से हम थोड़ा सा चेंज करेंगे, इसी के साथ वी विल प्ले विद इट. सो नाउ लेट अस चूज एनी नंबर x in A, and then we are going to use the equation 0.3. but equation कैसे यूज हो रही है, we are taking the mod of f of x, क्योंकि f को बाउंडेड शो करना है ना. तो इसमें क्या करते हैं, f of x में हम कुछ ऐड भी करते हैं और कुछ सब्ट्रैक्ट भी करते हैं. मैं f of k x सब्ट्रैक्ट करता हूँ. ये k वही नंबर है जिससे आगे आपकी कन्वर्जेंस होल्ड करती है यहाँ पर 0.3 में. तो f k of x को ऐड भी करेंगे, f k of x को सब्ट्रैक्ट भी करेंगे. तो अब ट्राइंगल इनइक्वालिटी लगाएंगे. ट्राइंगल इनइक्वालिटी लगाने से क्या होगा, इट विल बी लेस देन और इक्वल टू f of x minus f k of x प्लस mod of f k of x. तो ये वी आर चूजिंग, यू नो दिस इक्वेशन 0.3 में क्या है, 0.3 में जब भी आपके पास इंडेक्स f का ग्रेटर देन और इक्वल टू k है, तो यहाँ तो इक्वल टू k है, तो उस केस में आपके पास ये जो डिस्टेंस है एफ एक्स माइनस एफ के एक्स का, ये लेस देन 1 आता है, प्लस और एफ के जो है, एफ के इज अ बाउंडेड फंक्शन. वी नो दैट एफ के का जो मॉडुलस है वो लेस देन और इक्वल टू एम प्राइम है, तो सो दिस हैज टू बी एम प्राइम. सो व्हाट यू गॉट इन नटशेल, नटशेल आपके पास मिला कि whatever x is there in A, then this implies that mod of fx is always less than or equal to this fixed number which is m prime, and this is a bound, this is a bound, this is a bound, hence it implies that function f is bounded, f is bounded. Is it okay, is it okay that function f is bounded? Do you have any question in it? So no question. So we have this lemma, and what is the context of this lemma? Keep in mind, it says that the limit of uniform convergent uniform limit means when the sequence of functions is converging to function f uniformly, then f is called the limit, and convergence uniform होगी तो उसको uniform limit बोलेंगे. Convergence pointwise होगी तो we will call it pointwise limit. तो इन केस बाउंडेडनेस में सीक्वेंस की टर्म्स बाउंडेड है तो आपकी लिमिट भी bounded है, and we are going to use this lemma will be crucial to prove this theorem 4, where we have to show that product of uniformly convergent sequences of bounded functions is uniformly convergent. This is the context. So we are taking, be careful, we are taking bounded functions only, we are not taking arbitrary functions. Okay. So we have two sequences. Keep in mind, we have two sequences, fn and gn. ठीक है, तो एफ एन और जी एन का ही जो हम यूज करेंगे, और एफ एन आपके पास एफ को कन्वर्ज कर रही है, एफ एन इज कन्वर्जिंग टू एफ एंड जी एन इज कन्वर्जिंग टू जी. ठीक है, हमारा क्या क्लेम है, हमें क्लेम करना है कि अगर प्रोडक्ट करके मैं सीक्वेंस बनाऊं एफ एन डॉट जी एन, and you know how to define product of functions, so then it must converge to f dot g. So first we have to बहुत सारी चीजें प्रिपेयर करनी होंगी यहाँ पर. तो फॉर प्रूफ फर्स्ट लेट अस नो, क्योंकि हर एक गिवन है आपको कि सारी फंक्शंस बाउंडेड है, तो जीएन भी बाउंडेड है, तो हर एक जीएन बाउंडेड है तो हर एक जीएन का बाउंड भी मिलेगा. तो लेट दिस एम एन बी बाउंड फॉर जीएन, क्योंकि जीएन बाउंडेड है तो जीएन ऑफ एक्स विल बी लेस देन और इक्वल टू सम नंबर एफ एम ऑफ एन. ठीक है, दिस इज द इक्वेशन. लेट्स फिक्स दिस. और अभी लेमा क्या कहता है, लेमा कहता है कि यूनिफॉर्म लिमिट ऑफ बाउंडेड फंक्शन इज अ बाउंडेड फंक्शन. तो सो आपके पास g इज अ यूनिफॉर्म लिमिट ऑफ द सीक्वेंस g, और f is a uniform limit of the sequence fn. So g and fn are bounded functions. They are bounded functions, and let us choose their bound also. And m bound, let m be the bound for g, mod g लिखता हूं मैं इसको, क्योंकि mod of g जो होता है वो लेस देन इक्वल टू m लिखा जाएगा, और mod of f लिखा जाएगा लेस देन इक्वल टू l at some point x, at some point x. So let us take m to be bound for mod of g and l to be the bound for mod of f. और ये बाउंड हम यहाँ पर लेमा में डायरेक्टली यूज कर रहा हूँ. आई एम नॉट रेफरिंग हियर कि बाय लेमा दिस बाउंड्स एग्जिस्ट, बट कीप इन माइंड क्योंकि ये रिजल्ट स्टैंडर्ड है पीछे, तो वी आर एबल टू चूज दिस m एंड l बिकॉज ऑफ लेमा. क्योंकि लेमा, क्योंकि हाइपोथेसिस में g और f को बाउंडेड नहीं बताया गया, बट लेमा में हमने प्रूफ किया कि ये g और f भी बाउंडेड हो जाएंगे. ठीक है, एंड ये हो गए, ये सेटिंग हो गई. जी एन के भी बाउंड सेट कर लिए, मॉड जी और मॉड एफ के भी बाउंड हमने सेट कर लिया. तो फर्दर द यूनिफॉर्म कन्वर्जेंस ऑफ जी एन implies the existence of, we are again now using the uniform convergence, the existence of some and natural number positive, such that here we are choosing using the definition of uniform convergence for epsilon equals to 1. We are just going to brief, क्योंकि proof को not to proof को lengthy ना करें, we are not explaining everything. तो कुछ चीजें हैं. तो so for epsilon equals to 0, we are applying the definition of uniform convergence on Gn. Then by the uniform convergence of Gn, there will exist some natural number n greater than 0, such that Gnx minus g of x will be less than 1 for each x in A and n greater than or equal to n. This is the definition of uniform convergence. Now let us look at now for this n which is greater than or equal to ये capital N. ठीक है, पहले इसको देखते हैं. So again, what I'm going to do here, I'm going to take mod of gnx and I'm going to add something to it, and I'm going to add and subtract gx out of it, and then the triangle inequality will imply that this is less than or equal to mod gn of x minus g of x plus g of mod of g of x. Okay, and you know, we are choosing n to be greater than or equal to n, and we know that in that case this mod of g and x minus g of x is less than 1 plus this mod of gx Mod of gx, we have taken this mod of bound for this mod of g to be m, so hence mod of gx is less than equal to m. So what it implies? It implies that equation 0.4, then we get that mod of g and x is less than equal to 1 plus m for all n in n. So what it means that we are just bounding every n. We are just bounding every n by this number. That means whatever n you choose, provided n has to be greater than or equal to capital N. तो सारे GNs का हम एक ही बाउंड चूज कर पा रहे हैं. You may call it as a uniform bound also. But ये only true है for when n is greater than or equal to capital N. So we have to क्योंकि सीक्वेंस में आपके पास G1 भी है, G2 भी है, up to Gn-1 तक की टर्म्स भी हैं. So let's take care of these terms also. यहाँ से आगे वाली टर्म्स का जो रेंज है that is bounded by 1 plus m, and let's look at these terms now. इनके बाउंड्स हमें मालूम है, जो मैंने ऊपर बिगिनिंग में किया है. इसका बाउंड मैंने m1 रखा है क्योंकि ये बाउंडेड फंक्शन है. G2 का m2 रखा है, so on up to Gn-1 का I have taken mn-1. So what we can do now, we can take the maximum of all these. We have n-1 numbers here, and we have one this here 1 plus m, and we will have total n numbers, and let's take maximum of these n numbers. So finitely many numbers का maximum find करना is a okay thing. So this is what I'm going to do. I'm going to take a number which is maximum of these numbers. Okay, then for any n we will have, and any x in a we will have this thing. क्योंकि कोई भी n चूज कर लीजिएगा तो n या तो लेस देन n होगा या तो n ग्रेटर देन इक्वल टू n होगा. अगर तो n ग्रेटर देन इक्वल टू n है, if n is greater than or equal to capital N, then आपके पास mod of g and x जो है as we saw in last equation will be less than 1 plus m, and you see that 1 plus m is less than equal to m prime because m prime is maximum of all these. And if n is less than n, that means n या तो 1 2 3 कुछ भी हो सकता है n-1 तक, it has to be mn तक रखा है. But anyways, so this will implies that then in that case also mod of g and x will be less than or equal to uh, mn, but mn is less than or equal to m prime. So in any case, whatever n you choose, and for each x, for each point x of a, you're going to this modulus of g and x is less than or equal to m prime. So this should, we got this equation. You have to keep this equation, and this equation holds for every n also. You have to be every n and every x. ऐसा नहीं है कि ये जो m prime है तो this m prime is also known as uniform bound of the sequence. That means हमने sequence की हर एक term को एक ही bound से bound कर दिया. We are not taking, पीछे beginning में तो I was taking, we were having by definition each one bound for each function, but what, because of the behavior of uniform convergence, we have been able to found that this sequence is uniformly bounded. You may call it as uniformly bounded, or we are having a uniform bound. Uniform bound means एक ही bound पूरे terms के लिए. So we have, अब हमारे पास ground सारा prepare हो गया. Let's now take some epsilon greater than 0, and then we have to again use the definition of uniform convergence of the given sequences fn and gn. Then accordingly there will be two natural numbers. fn के corresponding एक natural number होगा और एक gn के corresponding होगा. gn के corresponding के will depend upon epsilon, and obviously both will natural numbers will depend upon epsilon. This is the definition of uniform convergence, and यहाँ पर epsilons की choice मैं खुद से choose कर रहा हूँ क्योंकि ये जो number है यहाँ it needs to be some positive number. ठीक है, so I'm taking this to be epsilon upon 2l क्योंकि l is a positive number, m prime is a positive number, and gn minus gn x minus g of x, I'm taking it to be less than epsilon by 2l for every n greater than or equal to kg and x in a. And similarly, the definition of uniform convergence gives us that fn x minus f of x is less than epsilon by 2m prime for all n greater than or equal to kg and x in a. So we are done now. Let's go to check, because हमें शो करना है कि f प्रोडक्ट कन्वर्ज है, तो we have to take fn x dot gn x minus f of x dot g of x. We have to show this to be less than epsilon. For some n greater than or equal to some natural number, we have to take that natural number also, which will depend only on epsilon. So here is this. Let us take k to be a number which depends upon only on epsilon to be maximum of these two numbers kg and k epsilon. Why I have taken this k epsilon? Because kg depends upon epsilon as seen in the previous slide. Kf also depends upon epsilon. So maximum of the two will also depend upon epsilon. And let us take n to be greater than or equal to this k. And now from equation, we are going to use these two equations 0.5, and we are going to use equation 0.6 and 0.7 also. I have written here repeated 0.5 and 0.5, but don't worry. Let's look at this thing. Okay. तो यहाँ कुछ चीजें उधर मूव हो गई हैं, कोई इशू नहीं, हम इसको लिख लेता हूं मैं. व्हाट आई एम गोइंग टू डू, एफ एन एक्स जी एन एक्स माइनस एफ एक्स जी एक्स है, तो इसमें कुछ ऐड करेंगे और कुछ सब्ट्रैक्ट करेंगे. मैं सब्ट्रैक्ट कर रहा हूं इसमें एफ एक्स जी एन एक्स, और ऐड भी कर रहा हूं मैं एफ एक्स जी एन एक्स. ठीक है, बाकी की टर्म ऐसे ही रखेंगे एफ एक्स जी एक्स. ठीक है, अब आप इसको सिंप्लीफाई कर सकते हैं. पहली दो टर्म्स में से आप जी एन को बाहर निकालिए. यू विल हैव एफ एन एक्स माइनस एफ ऑफ एक्स ब्रैकेट जी एन ऑफ एक्स. दूसरी लास्ट की टू टर्म्स में से आप एफ एक्स को बाहर निकालिएगा. इट इज एफ एक्स जी एन एक्स माइनस जी ऑफ एक्स. ठीक है, अब हमने क्या करना, अब हमने ट्राइंगल इनइक्वालिटी लगानी है. तो जब ट्राइंगल इनइक्वालिटी लगाएंगे तो इसका मॉडुलस लिया था हमने, तो ट्राइंगल इनइक्वालिटी से ये हो जाएगा लेस देन और इक्वल टू, मैं कलर चेंज करके थोड़ा डिस्क्रिप्टिव ज्यादा बना लेता हूँ. इट हैज टू बी लेस देन और इक्वल टू दिस थिंग प्लस लेस देन और इक्वल टू दिस नंबर. बट फिर यहाँ प्रोडक्ट है आपके पास. हियर वी हैव प्रोडक्ट ऑफ द टू फंक्शंस, और प्रोडक्ट में आपके पास मॉडुलस की प्रॉपर्टी होती है जी कि whenever you have product of two numbers, the modulus of xy has to be mod of x into mod of y. So I can take this modulus to be separately mod of f n x minus f of x and mod of g n x separately ले सकता हूँ. फिर इसी तरह mod of f of x I can take separately and mod of g n x minus this thing. ठीक है, तो ये इक्वेशन है यहाँ पर. ठीक है, अब इक्वेशन 0.5 में आपको जी एन एक्स का बाउंड मिला है. वी नो दैट एवरी जी एन एक्स इज लेस देन इक्वल टू एम प्राइम. और 0.6 में आई थिंक, या 0.6 और 0.7 में एफ एन एक्स माइनस एफ एक्स का भी आपको बाउंड मिला है, तो वो है लेस देन एप्सिलॉन बाई 2 एम प्राइम लिखा है. एफ एन एक्स माइनस एफ एक्स इज लेस देन, तो सो एम प्राइम डॉट एप्सिलॉन बाई 2 एम प्राइम यहाँ से आएगा, प्लस एफ एक्स का बाउंड है क्योंकि एफ एक्स इज ऑल्सो बाउंडेड फंक्शन, और एफ एक्स का बाउंड वी हैव टेकन टू बी एल. एंड जी एन एक्स माइनस जी एक्स, gnx minus gx we have taken to be from equation 0.6, it is less than epsilon by 2l. So this is epsilon by 2l. So अब इस लास्ट वाली इक्वेशन को देखिएगा और इसमें सिंप्लीफिकेशन करिएगा. m प्राइम और m प्राइम कैंसिल हो जाएगा. वी आर टेकिंग दिस टू बी पॉजिटिव नंबर्स. l और l कैंसिल होगा. epsilon by 2 plus epsilon by 2 will be epsilon. And now what happens, आपने कोई भी epsilon पॉजिटिव लिया और फिर आपने देखा कि एफ एन एक्स जी एन एक्स माइनस एफ ऑफ एक्स जी ऑफ एक्स जो है, it comes out to be less than epsilon for every n greater than or equal to k, which depends only on epsilon, and for every x in A also. And this is nothing but this is exactly the definition of uniform convergence of a sequence, and this holds for every epsilon whatsoever epsilon you choose. And hence it follows that the sequence obtained by by taking the product of the two sequences f and gn, that sequence converges uniformly to the product fg on A. So this is it. Do you have any questions, any queries? I'm open. है कोई query, कोई question?
sir.
So we do not have any.